We're going to finish up with this example from the last video. And so at the last video, we had figured out the Ka for the ammonium ion because this is an acidic salt. You need a Ka. We had reacted it with water. We were getting ready to do our equilibrium calculations. I'm going to ice this problem. Remember, liquids do not affect your equilibrium. So we're going to now pull this concentration of ammonium ion down, and it plugs in right here, 0.10 molar. 0 and 0. So minus x plus x plus x. We can neglect the x here because we have an initial amount to simplify our problem. So 0.10 molar is going to be the ammonium ion concentration. Ammonia is going to be equal to x, and hydronium ion is also equal to x. Now let me just go back because the video was ending and I wanted to clarify. So since this is an acid, acids are proton acceptors, he pulled the hydrogen off of the he's an acid. He's going to give a proton to the water. So he gives the hydrogen to the water, and that made it become hydronium. Now remember, this is the same as H+, and it left behind an NH3. So here's your ammonia, and this is your hydrogen ion. So Ka is equal to concentration of ammonia times concentration of hydronium ion, which is your hydrogen ion, divided by concentration of the ammonium ion. So we have the Ka from this part of the problem earlier. 5.6 times 10 to the negative 10 equals, now substituting in, this will end up being x squared over 0.10. Cross multiply, and we are going to then take the square root. And when you do that, you're going to find your x, which is your hydronium ion concentration. I'll give you a second to get that. Hopefully, everyone gets 7.5 times 10 to the negative 6 molar for your hydronium ion concentration. Now, again, look back at your equation. Always look back. What we found was hydronium, which is your hydrogen ion. So if we take the negative log of this, we will have the pH, which is what they ask us to find. So pH equals negative log of 7.5 times 10 to the negative 6. We have two significant figures here, so we need 2 decimal places. So the pH of this solution is 5.13. That concludes this particular problem. We will work on some more of these in class.